Sometimes the problem with the student graph isn't the graph type, it's the axis. If the scale is awkward or the intervals are inconsistent, the data can be difficult to read, even if otherwise the student basically knows what they're doing. Hi, I'm Miss Parrott, and in today's video, we're going to be looking at how to choose scale and intervals when you're making graphs for AP Biology. Remember, the whole point of a graph is to make a data table that's just a bunch of numbers into a clear visual so that you can see patterns and answer your investigation question. If you have a graph that's cramped and uneven, you're not going to be able to see the truth of the data as if you had scaled it and done correct intervals. Even experienced AP students have issues with graphs. Sometimes they can plot correctly, but it's hard to read, like if it's too small or just scaled wrong, too big, things going off the sides. A lot of students started learning how to graph when they were in like 5th grade, and they think that that is the level of skill that they're going to need for AP Bio, and it's not. They're actually not fluent yet. Students need to be able to choose correct graph type, scale, axes, and build it and construct it in a accurate, efficient manner under time pressure, like in FRQ of the AP Bio exam. If they have a weak scale or wacky intervals, it's going to throw the data patterns off and they're going to analyze it incorrectly as well. So let's fix those problems today. So our goal today is to go from 5th grade, I know how to make a graph, I can do it, to I can do it accurately, quickly, efficiently, under time pressure, given AP style data. So at the end of this video, we're going to be using the actual data from FRQ number 2 from this past year, 2026, which is pretty wacky, and we're going to be able to check and see if we've made it to fluency yet. But before we get into that, let's differentiate between scale and interval. So scale is the range on the X or Y axis. It's the range of numbers. Now, you can go from like 0 to 40, but scale doesn't always have to start at 0. Maybe it's 1.5 to 7.5, or 2 times 10 to the 3 micrograms to 2 times 10 to the 6 micrograms. Yeah, that's much more AP Bio style data that you're gonna have to see and know how to graph. The interval is the amount between marks. This is like the number we count by, whether that's 1s, 2s, 10s, 5s, 25s, 100s, whatever, or even 0.1s, 0.2s, 0.5s. Now that we've got that differentiated, let me show you the 20 square interval method, which will help you be able to pick your intervals quickly and easily for the AP Bio exam. So on the exam, AP Bio often uses a 20 by 20 square grid. Now, this method could be used for any number, like you just count your number of squares and put that number in place of 20, and it will work just the same. Even on the AP Bio exam, you do want to still count and be sure that it's 20 so that you're not assuming the wrong number. So, for a 20 square axis, the first thing you're going to do is find the highest value. Now, that's not going to be your max, but it'll help you choose the correct max. So once you found the highest value, divide it by 20. That's or whatever your number of squares is. Then you want to round that value up to a clean interval. We'll talk about what a clean interval is in just a second. Then you're going to multiply that clean interval number by 20 to get your scale, your max. Your scale's max. Now, once you've done that, and you've kind of put that, your min and max, you want to think to yourself, does the scale use enough space? Now, what counts as enough for AP Bio? It's not a feeling, okay? You need to be using at least half of the space, both horizontally and vertically, in your graph. So between 50 and 100%. And really your target amount of space needs to be somewhere between 70 to 90%. So you want a little bit of breathing room, but you still want it to take up the majority of the space. Now, clean intervals, right? Remember, intervals is what we count by. A clean interval is going to be something that is quick and totally not difficult math to do in your head that you're going to have to think about hardly at all. So things that have 1, 2, 5, and 0 on them, those are the quickest and easiest. Even if it's decimals, 0.1, 0.2, 0.5. Those are quickest and easiest for our brain to do and not mess up. We want to avoid big decimals, like multi-value decimals, 3, 4, 6, 7, 13, 17, or a number like 19.4 or even 12.5, because those intervals you have to think, and you don't want your brain to be wasting time counting what's next on the axis instead of actually building the graph, right? We don't want our brains to work harder on building the axis than on actually interpreting it and writing the answer. Time management is a huge part of AP Bio exam fluency. So choosing intervals helps save you time and gives you more time to get more points. Let's work an example together. All right, in this one, I've got time in minutes here. Every 2 minutes there's time. And then what's being measured, my dependent variable, is oxygen production in milliliters. So I've got that here. Our goal, again, is to find what should be our scale and what should be our intervals. So our highest value is 38. Now we're going to divide 38 by 20, and that comes out to 1.9. So 38, divided by 20 is 1.9. 1.9, not a clean interval. So we're going to round up to a clean interval. The closest one to that is 2. 2 is easy to count by, right? Then we're going to multiply this number by 20. So 2 times 20 is 40. And that's going to be, and on this case, our lowest is 0. So we're going to go from 0 to 40. And then, is this interval clean? 2, yes. Is our range going to fit our data? Yes, because 38 is like a whole, it's 90% of 20, 95% of 20. So that's in our target range. So yes, that's good. Now that's a pretty simple one. Common mistakes that students make when choosing scale and intervals. 1, they'll do uneven intervals. Now this is only okay if you're using a log scale, but even then you need to be using powers of 10. Another common mistake is having a tiny graph in the corner. Again, that could be perfectly accurate and you're still going to earn some points for it. You're going to lose points needlessly for having too tiny of a graph that's difficult to read. Having awkward intervals, that's never good. Or just copying the data values as your axis labels. It's gonna end up with your graph just looking like a line, a straight line, and that may not be a true representation of your data. Well, sometimes it would be a straight line, depending on which axis, but big picture. All right, now it's very important for us to remember that making errors, doing this wrong, having to erase, having to get a new piece of paper, that's part of the process. It's part of the learning process. It's how we go from can do to fluent. So practice, when you're practicing or having your students practice with different types of data and different ranges of data, right? Some very small, some very huge, some in between. Be sure you're using pencil with an eraser because mistakes are gonna happen. and have some extra pieces of graph paper, because sometimes it's better to start over than erase. All right, like I told you, we're gonna see if we've really got this process down. So this is the data table from FRQ number 2 in 2026. This was released on the College Board website. So the data table threw some people for a loop. Now, I added one thing. I added the word amount here because it just gave, here's gene G and gene H, and then mRNA in AGO2++ cells, plus or minus 2 standard error of the mean. Yeah, that's what AP Bio is about. And then 3 groups with different genotypes. All right, and then it had numerical values with decimals and plus or minus standard error of the mean. So, right, that's a lot more complicated than our little 0 to 40 intervals of 2, right? So, first of all, they didn't give a unit on the data table. The word amount is in the sentence right above this where it's describing the data. So, this is tricky because that very first step, finding your highest value, is going to be a little different if we use error bars. So in this case, our highest value, we've got 1.0, 0.92, 1.53, 3.0. But it's not just 3.0. It's 3.0 plus the max that the error bar needs to reach is 0.4. So 0.4 on top of 3. So our actual highest value, including the error bar, is 3.4. All right. Then we're going to divide that by 20, which is going to be 1.17, I believe. Yeah. Always double check. Then, and 0.17 is definitely not a clean interval, but we can round it up easily to 0.2. 0.2 is a nice clean interval, and we don't want it to be 0.20 because if you look, all of our data here is going to tenths, so we can round to the tenths. All right, so we can make this 0.2. Then we'll multiply that by 20 to get our axis max. So 0.2 times 20 is 4.0. Now, if we have 4.0 as our max, and then our axis max, and then 3.4 is our highest data value, is it going to fit the space well? Yeah, that's going to fit like 17 of the 20 boxes. And that is like right in our target range. So that's going to be 17 out of 20 boxes. That should have been 4.0 divided by 20 boxes is 0.2. So yes it does. So fluency is our goal here. You've got to practice. What's your scale? What are your intervals? And remember, scale doesn't always have to start with 0. You know you're fluent if you can look at this data and do this whole process quickly and easily and to the best ability in your head without having to slow down, to use a calculator, or to erase and redo multiple times. Everybody has to erase sometimes, but we're not trying to do it 5 times, maybe just once. If you found this video helpful, please do give it a like, subscribe to my channel for more AP Bio skills videos, leave a comment, question, or an emoji down below, and teachers or students, check out my Teachers Pay Teachers store, Know and Grow with Gnomes, for practice in graphing, AP Bio style graphing, and data analysis work. Keep learning, keep growing, and we'll see you next time.